The most fun part about this is hitting live and wondering how long it takes to travel, for the bits to travel from me to the internet, but also back to you and then back to YouTube again. As far as I can see, we're live. So happy time zone, everyone. Happy Wednesday. Very excited to have you all here. Some new faces, some old faces. As per usual, let's start with you, Charlie.
Hey, what's up?
You want to introduce yourself to
Hi.
our audience?
I'm Charlie Voiselle. I've been here at HashiCorp for a while. I work on the Nomad team. I'm now a Nomad engineer. Heyo.
Yeah, because I remember last time
from Educación.
Exactly. You switched over. Anthony, first office hours for you.
What did you do? Yeah. Very excited to be here. So I took over Charlie's old position and I kicked him out. And I said, I'm the new Charlie, and I don't think I've lived up to it. But I'm on an education team. I write a bunch of stuff for Waypoint, Vagrant, and Nomad because, I don't know, they can't have three of me, so they just get one of me.
I think that works perfectly. So if you're just joining us, welcome to the Nomad office hours. It's been a while, but we're back. Very excited to have these two guests here because we're going to be talking about some fun stuff today, specifically quick start on AWS and application load balancing for external traffic. As always, with our events, yes, this is a virtual space, but that still doesn't mean that we can make inappropriate jokes. We can make funny jokes. We just can't make inappropriate jokes. So as you join us in the chat, be welcoming, inclusive, and friendly, and patient at all times. We're working with technology. Technology is hard. And give us a benefit of the doubt if things don't work out. We have live demos for you, which means they will fail live, potentially, which is the most exciting part. As you leave comments, as you leave feedback, be considerate and respectful. And of course, if you have more thoughts or concerns about our community guidelines, head on over to hashicorp.com/community-guidelines. And if you're in the chat, feel free to say hi, just like James did. Good evening, James. Hello, nice to see you again. And with that, Anthony.
Yes, sir.
Why don't you kick it off for us?
Awesome. So I told Kerim before I can't actually see anything. So if there's any questions that pop up in the chat, feel free to put them there. And then Kerim and or Charlie, someone will tell me what they are. And if I can answer them, great. If not, someone smarter than me will. But today I'm going to go through a demo for managing external traffic with application load balancing. So wrote this about a month ago. It was really fun. I found it very useful. So we're going to go through that today. For anybody that's not familiar with application load balancing or needs a refresher, application load balancing is a concept that focuses on routing and balancing traffic based on the 7th layer of the OSI model, known as the application layer, which is a fancy way of saying we're going to do stuff based on whatever we have in the URL path. That includes query parameters, paths to specific resources. So if we look at the little diagram here, 2 requests coming from a user, one for /app/account/balance, and one for /HTML/about us. So these both eventually go to the application load balancer, which analyzes this URL path and has basically a chart or a set of rules that says, based on whatever is in the path, I will do something with it. So in this case, there's a configuration in here that says anything on /app, send it to our application that's running in Nomad over here. Likewise, anything that's /HTML, send it over to GitHub pages because that's our static website, and we don't need to do any further processing with that. So there's a bunch of other text here that describes the scenario a little bit more and application load balancing. But to keep it as brief as possible and only have the really good stuff in the presentation, I'm going to go ahead to the infrastructure diagram we have here. So what we're going to be setting up in this scenario is our Nomad cluster in AWS and an application load balancer beside it. So our cluster setup is consisting of 3 Nomad servers and then 5 Nomad clients split between data center 1 and data center 2, 3 in data center 1, 2 in data center 2. And the reason we're doing this is to basically emulate a scenario where we have specific clients that are handling specific parts of our application. So in this scenario, we're saying, despite them all being the same clients, there's nothing special about them. The ones in DC1 are handling requests going to the API service, and the ones in DC2 are handling requests that go to the payment service. If we were to say a real world like application of this, we might say the payments clients have faster storage or higher memory, which allows them to quickly process payments. But again, in this case, there's nothing special about them. It's just for an illustration. And then the other thing I want to point out is each of these clients has a attribute, a metadata attribute assigned to them based on where they are. So each of the clients in DC1 have a service client attribute with a value of API, whereas the ones in DC2 have service client of payments. And this will come up a little bit later when we actually run our Nomad jobs, so that we can specifically run different application or parts of the application on specific clients. So these are just snippets from the Nomad specs. If you check out the application repo or the tutorial repo, it's all in there. And I completely forgot, Kerim, if you could put this link to the tutorial in case anybody wants to follow along. That has links to everything I'm talking about, the repo, everything you'll need to get going. So with that out of the way, this is the actual scenario, or the more like the application diagram for the scenario we're going through here. So DC1 and DC2, we can see that we're running our app on each client in both data centers. So we have 5 instances total because we have 5 clients. But we also see that our Nginx, which is acting as our internal load balancer for each of the data centers, there's only one running in each data center, and that's responsible for forwarding requests to each of the clients in their respective data centers. And the way the application load balancer is set up here, to allow incoming traffic, we make it listen on port 80, and then we forward those requests to port 8080 on any of the clients in either of the data centers. And the reason we're doing that is we're not specifying like a service here. We're just specifying a port to keep it as simple as possible. So we're directly sending it to port 80, and then any client that has Nginx running on it will serve that request. And then because it's an internal load balancer, it will forward that to the specific applications. I'll break here for a second. Does that make sense? Is there any questions in the chat? Anything I should know about?
No questions at this point, but we've shared the link to the tutorial.
Fantastic.
Of course, as always, if you have questions, drop them in the chat. We'll answer them live.
Yeah, we'll do it
Anthony
live.
is prepared for everything.
Totally. So the other thing I wanted to mention was if you're following along and you're thinking, what happens if the application load balancer sends a request to a client that doesn't have Nginx running? Is it going to fail? What's going to happen? The application load balancer has health checks enabled that basically says, I'm going to check each of the clients that I have access to, so both data center pools of clients, and check, is there something running on port 8080? If not, then I won't forward anything there. So as far as the load balancer is concerned, it can only send it to this client in DC1 and this client in DC2. So we're not worried about like 404s or timeouts or unresponded requests, I guess is a way to put it. So now to jump into the fun part, which is the actual scenario, since we've gone through all the setup. If you want to follow along at home, feel free, but I'm going to blow through a lot of this because as Kerim mentioned, the demo gods are not always nice. So I've pre-set up my cluster ready to go. But if you want to follow along, we're using Packer to create the AMI Amazon machine images for the instances. We're using Terraform to then deploy everything, including our load balancers, and then obviously have Nomad for connecting with the cluster and actually doing stuff. And because we're running in AWS, we're using an AWS account that has our credentials set up locally. And I've set all that up here. And to prove that it's there, I'm going to do it real quick. So there's my AWS setup. Check Nomad. So we have our Nomad address set up and our Nomad token. And if you're following along at home, there's a post setup script that you run after the initial Terraform set, which will grab the Nomad token that's temporarily stored in the console key value store, and then make it available locally so we can continue to make requests from our local machines. So one last thing that you can check is make sure nothing has died in the process. So we'll check on our nodes. Everybody's great. Check on our servers. Everybody's alive. This is fantastic. In the tutorial, we're going to go down to the run the application job since we've already set up the cluster. So I mentioned that, I think I mentioned that we're targeting specific clients based on a metadata tag. So I'm going to point those out real quick. If we hop over to our topology page in Nomad, actually go to clients over here. Hopefully this is legible. That looks terrible, but hopefully this one's legible. So these are the 5 clients that we've set up, and we can see that they're running in DC1 or DC2. If we click on one in DC2, let's say, and we scroll to the bottom, this is the custom metadata tag that we created. So service client, and then the value is payments. So this is payments, which means it's running in DC2. If we check on one of them running in DC1, we will see that this one has a value of API. So likewise, when we actually run our jobs, if we look over in VS Code here, the way we're doing this for Nomad is we're using the constraint attributes, and we're saying anything that's running in this group, so that the tasks that are created, we're applying a constraint that says only run these if the client has the service client attribute and is set to API. So that's how we're basically saying only run the APIs in DC1, only run payments in DC2, and then for the payments, it's using payments instead of API. And this also applies to the Nginx tab. One for API and then one for payments. Cool. So that's a whole bunch of talking. We're actually going to do some stuff. So if we hop to the jobs page here, we can do a Nomad job run. And then there's 2 files in here. One is our web app. So if we run this, Nomad's going to start placing our instances. If we refresh the job page, there's our demo job or demo web app job. It's placing everything. Hopefully it'll go quickly. The other thing I really want to point out is I discovered this fairly recently, which I wish I discovered it earlier, but there's a topology page in the Nomad UI, which is just like chef's kiss, so good, because it shows you each of the nodes like in a 1-page dashboard view. It shows you each of the nodes you have, and then additionally each of the jobs that are running in there. So this one's still starting, so it's grayed out. But once it's complete, you'll see that it turns green. And like, I love it because at a glance you can see here's where all of my stuff is running. And in this case specifically, we can see that each of our demo web app jobs are running one task on each client in both DCs, which is exactly what we want, which is amazing. Technology some days is just perfect. So with our wrap up, we can launch our Nginx job. And again, this will launch 1 instance of Nginx in each data center. So we see here replacing 2. And if we go back to the topology page, we'll see that it's placed it on the 3rd instance here and the 2nd one there. All right, so now we have our web app instances up and running. We have our Nginx up and running. So now we have to create our application load balancer to actually start forwarding requests to Nginx. So to do this, we go back to our Learn guide here, and we go down to the Create Application Load Balancer. So we can copy and paste this as is, and we're going to create another file under our AWS directory. If VS Code would work with me, call it alb.tf. Paste this in here. Do our Terraform apply, and hope that it works. So far, so good. Perfect. All right. All right, deprecation resource, but it looks like it will create what we want. So as that's going, I'm not going to go through all of this because you can read about it if you want later. What this is doing is creating our application load balancer to listen on port 80 and then forward requests to 2 different target groups. So the way this is set up with the Terraform code is basically the clients, in this case, Nomad _ clients, are the ones that are running in data center 1, and Nomad clients targeted are the ones running in data center 2. So as it is right now, it's forwarding to both target groups. It doesn't matter what the path is. By default, it's just splitting the traffic half and half. And then each of those clients are configured to listen on port 8080. So it'll take requests on port 80 and forward it to these clients on port 8080. So while we're waiting for the ALB, are there any questions or concerns or anything I should know about? Talking too fast, text too small, hair too long? Anything I should know about, Kerim?
I think the hair looks fabulous today.
Oh, thank you.
With regards to questions, we had actually a thought of using Trafic instead of Nginx.
Perfect, yeah.
Macy suggested that. And
Yeah.
Amir also responded to that.
Say again?
Amir also responded to that. But what do you think about using Nginx versus Trafic?
So I'll be totally honest. I use Nginx because I've used it in the past and it worked. But so this is also something I wanted to point out. But thanks. I didn't catch who said that, but thank you whoever pointed it out. There are actually guides for load balancing with Fabio HA proxy and Trafic right now on the Learn site. So you could totally use Trafic if you prefer over Nginx, because it's functioning as an internal load balancer. As long as it has a port that it's listening on, this is basically cut and paste Terraform code, just changing whatever port you want it to. But you could totally use Trafic. I, again, used Nginx because that's what I knew. If you know something else, fantastic. Go for it.
I think that's how a lot of operations technology works, right? You're used to a tool that works. Why change it if it doesn't solve necessarily a new problem?
Exactly.
One other thing I want to call out, all the workflows that Anthony is describing, we have tutorials for. If you want to learn how to build Packer images, there's a Learn guide available on learn.hashicorp.com. Same for deploying the stuff with Terraform in AWS or any other cloud. And even upgrade guides on how to deal with deprecated resources.
Which I should totally read after this. So maybe send me that link.
I think we'll publish that link, yes.
Perfect.
And with that, back to you.
Yeah, so we're just waiting a couple more seconds. I think this takes about 3 minutes to fully deploy the ALB. While we're waiting, we can check out the AWS console. And we see here, so this is the load balancer that we're creating or waiting to be created. And it's still creating listeners. Perfect, there we go. Okay, so we can take this ALB address from the output. So this is the public ALB address that it gave us. Right now, it's not completely loaded yet, so Nginx is still, okay, now it is loaded. Technology works quickly. So if we take a look at this teeny tiny page, the web application is super simple. All it does is say, welcome, you're on node, and then whatever IP address it is. So if we refresh this a few times, you'll see that it changes. And if you have a real keen eye and you're counting, there should be 5 unique addresses there. It might be easier to see if we run this curl command. So 1, 2, 3, 4, 4. And there's a different one, 171. So I'm not lying. There are 5 unique addresses here, which means each of our 5 clients are receiving requests and they're giving us responses, which is exactly what we want. So this might not work exactly the way you want, given the scenario we have where we say one part of our application is only on one set of clients and the other one's on the other. So next, we're going to modify our ALB configurations to do just that. So we jump down to the target specific client section. There's another snippet of Terraform code here. So we copy this and add it to our alb.tf file. Make sure we save, because that's bitten me a few times. And we do a Terraform apply. Terraform is going to do its stuff. And I will say, yep, and where it's deprecated, I will fix it eventually. But what this is going to do is basically create 2 listener rules that says anything that comes as a request / API, send it to the Nomad clients target group, which is the ones in DC1. Likewise, anything on /payments, send it to Nomad clients targeted, which is DC2. To further illustrate this, if we check out the listeners for the ALB we created, we can see the rules here. So like I said, anything with /payments, go to clients targeted. Anything with API, go to the initial set, which is DC1. And then this is probably not how an actual application would be configured, but anything that doesn't follow those paths, we're just splitting it half and half. This is just to keep it as simple as possible, but you can definitely fix that and make it actually work like it should. So now that we have the rule set up, if we were to run the same curl command that we had, but we run it against /API, I'll open this up quick. So if we run API, we'll see that there should only be 3 IPs that come up. So 177.81.208, and they match up to the 3 we have in DC1, 177.81.208, which means all the requests to API are correctly going to just the clients in data center 1, not data center 2. And if we were to do the same thing, but use payments, there only be 2 different IPs here, 113, 171. And again, those match up to just the 2 clients we have in data center 2. So that's the extent of the demo for the tutorial. And it goes so much quicker when you have the cluster set up. So I'm very glad that everything worked out. A couple of things to point out. One, as the commenter mentioned, you can totally use other internal load balancer software if you want to use traffic, HA proxy. I forget what else there was. But again, we have specific guides for those if you need a refresher on how to set those up. And again, like I mentioned with the rules, this is probably not how it should be working, because if it's forwarding half an hour because the proper application is not responding. So you can fix this to send it to maybe like a static HTML website or a generic controller that does whatever kind of routing that way. Additionally, you can set up 404 pages that says anything that can't get fulfilled by /API or payments or what have you. You can say specifically, send that to the 404, and then just generically say, I don't know what to do, man. We'll figure it out, though. And I think that's all I got. That actually went surprisingly well. Anything else from the chat, Kerim?
That definitely went surprisingly well. This was a beautiful demo. I like the call out to traffic splitting. I think 50-50 makes sense if you're balancing across different regions, not just availability zones.
Yeah.
Make it easy for your content to be reachable. Maybe you'll even bring in some more edge logic to make sure, European customers go through European clients and everything. Plenty of options there.
Totally, yeah.
And
there's a lot you can
do. Go ahead.
I was just gonna say there's a lot you can do with it, but to keep it kind of digestible, we have to cut it off at some point. So this is why we have routing 50-50 split, which is not the best, but it's something we have to do.
It definitely works for the demo. So good question here. If I added an accelerator to my ALB, would this work the same way?
I'm unfamiliar with what the accelerator means here in context, so I don't know how to answer that.
I'm guessing Amir will provide some insights into that, because I'm also a tiny bit confused here. Are you thinking something like Cloudflare or something else that caches things before it even hits the ALB?
Like a content CDN or something.
Yeah, maybe.
Yeah.
AWS Global Accelerator. That is a super good question. And I want to say, what we're going to do is have office hours for the AWS provider. We'll get somebody from AWS to answer this question for us. Yeah, I feel like that's the right approach here.
Yeah, that's the great approach, because to point out, we're people, technology fails, sometimes we fail. In this case, I failed not knowing an answer. So this is when we just say, all right, let's get AWS in here. They know their stuff.
I think that's the correct approach here. So with that, I think if you have any other questions for Anthony, drop them in the chat, because you'll stick around in the back end. And with that, let's bring Charlie back.
Well, hello, everybody.
Welcome back.
All right. So
are you ready to give us also?
I am indeed. So today I'm going to talk about the AWS Nomad Quickstart, and it has been around for quite a while, and it has sadly gotten not a lot of love, but finally, after doing a gigantic cloud formation template redo to bring it up to their new YAML syntax, we were able to get this template running on current versions. I will warn everybody who comes to this particular page here, the HashiCorp Nomad on AWS page, that you are going to run into some stale content still. We're currently working with them on documentation, but they were gracious enough to let us get the template out and deployed first, so y'all could benefit from newer, better for the folks that are using CloudFormation. If you don't know, the CloudFormation template will build quite a large Nomad HashiStack build out that will look like this. This is the old graphics, but those two will be updated. It builds a VPC with the Linux Bastion. It will build NAT gateways. You can put them in multiple AZs, and it will build a console server ASG, a Nomad server ASG, and a Nomad client ASG. So you can use this to build quite complicated layouts with just some point and click configuration. One more warning for anybody who happens to come this route. Typically, you would use one of these links here in how to deploy to jump over there. I'm going to select the deploy into a new VPC. That will bring me to the CloudFormation create stack. Yet one other piece that I just noticed today, because yay demos, is that this URL will need to have .yaml appended to it. I'm going to work with them to figure out why that's sad, and we're going to get that updated. So now that you have corrected the S3 URL for goodness, we'll click next. And here's where we get to start defining things. You can build a stack with a name it whatever you like. Here's where you define the VPC stuff. So in this case, right now I'm in US West 2. Suppose I wanted to spread out across A, B, and C. You get all of the CIDR definitions in VPC for your public and private subnets. That all comes from their AWS VPC stack. It's a included stack for this one. You can set your permitted IP range. I recommend everybody who builds this stack using this sets an IP range so that they're controlling their ingress. You need to set a key name that's going to be inside of your AWS environment. So for me, it's going to be that one. You have some exciting options about would you like to build a console cluster to support your Nomad? Because Nomad can be rolled out with or without console. It's very convenient to be able to have a console cluster automatically built for you. You can set instance types, number of server nodes, and whether or not to go ahead and pre-enable service mesh or connect. You have the same sort of options for your cluster setup for Nomad. We give you the option. You can set your server and client instance types and counts. So for your server nodes, we provide options for 3, 5, and 7 because those are the very, very typical quorum settings. And we default to 3 Nomad client nodes, but you can adjust that to whatever you might like. This is an interesting section here, the DNS and SSL configuration. If you have access to Route 53, the stack will build a proper cert for you, check it out, and apply it. Or if you are not, in my case, I don't have access to the Route 50 to a dynamic Route 53 domain. So there's a cheat here. There's an escape valve where you can supply your own SSL certificate ARN. So like in my case, I have an IAM cert that I'm going to use for mine. So we'll see it be sad about privacy. Last but certainly not least, the 2 magic buckets that make it all happen. Where's the quick start? What quick start are you using? So hit next. We need to look at the last bits of awesome. In AWS fashion, you can apply tags to it. You can, if you do not want to use the role you're logged in as, yes, and OG2, this is a CloudFormation form. This is when you build the templates, it creates this very actually kind of nice text UI based on the defined permissions. And let's see. So, but you do get here, you get to set you can override the IAM role name that it builds the stack as, or you can let it build it as whoever you're logged in as. And then CloudFormation has their stack failure options. If it blows up, what do you want me to do? Sometimes it's very handy to leave things so that you can troubleshoot them. And they're all CloudFormation advanced options. Last, and here's where you get to the confirmation page, and it just lets us check everything that we put in there. Just the great summary of the universe. And scrolling all the way to the bottom, 2 magic check marks, because this will build things that cost money. And they want you to know that. And there are some IAM resource buildings that it does. So you have to check both of those things. When you want to run, click Create Stack, and it will start building. Now, because this process takes about a half an hour, I have already built one, and we can jump over there and look at it. So after it starts building, it looks something like this. It starts by building the stack you define, which consists of a VPC stack, a Bastion stack, a Nomad cluster stack. And a Nomad cluster stack contains your console servers, your Nomad servers, and your Nomad clients. Once everything builds and all the creations are complete, you can look at your HashiCorp Nomad stacks outputs, and you get 2 ALBs. One that points to the console server UI and your console servers. One that points to your Nomad servers. And these are also, you can submit work to your cluster. Right now, the way this stack is built, there's actually no client ingress set. You can use any of the other ways to build a client ingress so that you can talk to your workload. And this is a sort of a great dovetail from Anthony's tutorial where he was creating that application load balancer that was running on the clients and using an AWS ALB that he was building separately to provide ingress to that Nginx so that he could have access to his Nomad client workload. This case, what we'll just have is just access to the servers so that we can submit work. So now, just so that you know that I'm not lying, if I right click on this and open it in a new tab, ta-da, it's a Nomad cluster. If we look at topology, you'll see that right now we have 3 clients chilling out in DC1. If I go look at my clients here, I can see they have very Amazon-y looking names. I can see their IP addresses. And let's see, I'm going to bring up a little shell situation. Find the right one. Slide it over here. And so to connect to my exciting cluster, it's that same URL right there. I'm just going to get my CLI ready to use it. So you would override Nomad ADDR like always. Now, because my cert is not real, I'm going to have to rely on a crutch and use Nomad skip verify. But that's just because it's a fully self-signed garbage cert. But now I can run Nomad status, no running jobs, Nomad. All right, so let's run Nomad and it will run the example job, right? Of course it does. Gotta love. Do it again. Charlie. There we go. And write example.nomad. I'll do a nomad job run example.nomad. Do the magic. And we can actually even peek over here. Get a little reloady situation. There we go. Now, oh, look, example. It's running. I'm in the middle of a deployment. So good. Gonna go look at my allocation. Running. Oh, even better. Gonna go into a task. Gonna go check out some logs. Yeah, look at that. I got logs from my example job, which is a very happy thing. The other cool thing is, and this was actually one of the upgrades that happened while we were refactoring this from JSON, the old CloudFormation JSON, to the new YAML syntax, was realizing that the UI had actually made gargantuan leaps since the last time this whole stuff was laid down. We ran into WebSocket problems, and we had to upgrade the legacy ELBs that it was using to ALBs so that exec can now happily work. And of course, that container only has sh. CD/ so that we can see some files. Yay! Look at that. All right. So Nomad exec works like one would expect. We got tiny little stats going on. This is a very relaxed container. If I go back to my topology view, we see that that did land on one of my 3 magical clients that I've built. So life is very good. Because it's a CloudFormation stack, you can also issue change sets against it, which is very, the CloudFormation idiom for an update, a state update. Oh, and also to show that this, if memory serves, the sample job does in fact register. Where are you at? There we go. Sorry about that. We're going to go open up the console ALB. Going to let it think a second. And we can see the Redis cache service, which is built by the example job. So when the example job runs, it creates a service named Redis cache. And if I look at that, I can see its internal address. Then this is one of the reasons why that application load balancer magic, the ALB, and your internal application load balancer are important, is because in console's case, it wants to give internal IP addresses. So this is the inside of the cluster IP address of the Redis service. And really, that's, I hate to sort of belabor a demo longer than it needs to be, but that is the beginning of the beginning. And, from here, you can turn on ACLs, do other extra cool things. You have access to all of the nodes through the Bastion host, so you can SSH into them. It is pretty right on time, and lets you do more things. So here's the ugly. As I mentioned, the documentation is a little bit stale. If you're a friend of Nomad, then you will have very little challenges adapting. And even there are not super profound changes to the CloudFormation forms. So it will feel the same, but it's ugly. We are, like I say, working on updating all the docs to the new way they like to generate them, and that's coming soon. I think that's the high points.
There's a lot of high points here. I like this demo a lot. We had a couple of really, really good questions coming in, and James has been kind enough to answer some of them. But for the people not checking out the chat, let's start with this one. OJ asked, how does Nomad handle configuration files like the config store Swarm uses? And then followed it up with, can you store it in console? And these configuration files for the jobs running on Nomad these are the configuration files for the jobs running on Nomad. And it continued from there. It's beautiful.
Yeah.
It's actually, as we're talking about this, the answers reveal themselves. This is the magic of live demos.
It's true. And I mean, the other thing is that because you can always use console template as a standalone to just emit data from console back to file, you can trivially use console template to create your job configs if you want to send those. There are also other UIs that can help you put together complicated job specifications, from Levant, Nomad Pack, which we're working on, to creating template, and then or also even console template itself.
Plenty of different options. Nomad Pack definitely deserves a shout out. And I'm wondering, actually, can I get you to explain to our audience what Nomad Pack is? And I'll dig up a link.
Kerim, you're the worst.
I know. I'm sorry. I know we didn't approve this beforehand.
All right. If you want, you can stop that share. Give us some more screen. Then people can get a better look at me. So Nomad Pack.
Back.
Yeah. Hey. So Nomad Pack is our take on. Ooh, someone's feeding back audio. Our take on a job templating engine using metadata, or that provides metadata and can create reusable job deployments. I'm going to use a dirty word. It's not entirely unlike Helm, but for people who might be familiar, it actually uses similar templating. We use the Sprig functions like Helm does. It is a flavored Go template based templating language. So rather than using the typical Go template double curly braces, we use square brackets. And that's actually because in the case of Nomad, the Nomad template stanzas, double curly braces matter. They're significant to Nomad. So it was going to be easier for people if we didn't create conflict. This pattern was already done in Levant. James, my hero, we brought it forward to Pack. Golly, I'm trying to think of one of the nice things about Pack, though, specifically, is you can define a subset of variables and offer them to people, not unlike the way HCL2 dash vars or even Terraform provides var flags. So you can set variables in the environment. You can override them with flags. So you get a lot of flexibility with regard to the environment you may be running Pack in. One of our goals is to help simplify the CI/CD story. I will say that that is a work in progress. Pack is at Tech Preview 2, Tech Preview 3 coming soon. And I am the soon. But it's very, right now I'm working on exciting issues with nested dependencies, for example. So that's where I'm at the moment. But I think it's going to be pretty sweet. It will be, I encourage people to grab it, play with it, acknowledge where it is in its development life cycle, and certainly file issues. And also, as people do file issues, make sure that you're checking out what other people are filing, upvote them if you think it's important. Please use the thumbs ups on them. We check that. And that will help our product team prioritize the fixes that y'all find most important.
And I want to just repeat that for everyone once again, because it is important. The feedback you provide us for Nomad Pack and any of our other tools goes to shape the product. This isn't to say that if you complain about a piece of documentation not being perfect, that all of a sudden we'll release a new major version and fix it. But we take that feedback on and we adjust our roadmaps if we see enough demand for a feature. So grab the Learn Guide that we just linked in the chat, also in the video stream. Check it out, see how Nomad Pack works for you. Maybe there's packs that are missing. Feel free to add them to the community registry. Maybe update existing Nomad packs. But also same call out with the quick start. If you feel the documentation could need some help, I'm sure we'll take that PR on. Documentation work is very much the core of open source work. Even if you don't feel comfortable writing a scheduler algorithm, I definitely don't, doesn't mean that you can't write some documentation that helps the next person understand why a certain workflow works the way it works.
Indeed. I do love a docs PR. I will not lie. Every time I see one, my little heart lights up, because it is one thing that I didn't have to necessarily field trip onto, and that also means that somebody used it. And I'm sorry that they stubbed their toe, but I'm glad that they're making sure they move the table so nobody else does.
That is a beautiful way of explaining it. You don't have to wait with docs PRs until Doctober comes around and you're trying to get a couple of PRs in for Hacktoberfest. You can send them in at any point. They might make it into the next version of Nomad or Nomad Pack or anything, and we appreciate them. And maybe you'll help contribute to new features. We're one big community, and I'm excited for everyone's contribution here. Meanwhile, we've got a new question or feedback coming in from Shantanu. Nice to see you again. Give me a second to collect myself for this one. So this is live because emotions are real and emotions are hard to control. But how can I rationalize the emotional roller coaster ride when a bug file goes from submitted, given a milestone, and then removed from a milestone? It's hard. I think the best way to deal with that is to redeploy your infrastructure and see which parts you can improve upon. Because during that process, you will come across things that weren't optimally working. And maybe there's new feature requests you can make and bugs that can be filed. Anthony, anything you would like to add to that?
No, but I'll take it back to a little bit of a serious note. And there are actually, I'm looking at the registry now, there are Nomad packs for Traffic, Nginx, HA Proxy, and Fabio. So to go back to my presentation, if you wanted to switch out Nginx, you can try using Nomad Pack with anything else that's there. So Nomad Pack's coming along.
Nomad Pack is definitely coming along.
And it's funny, I do definitely, I can sympathize with the emotional roller coaster ride of watching a thing get scheduled and then watching it be descheduled. I think that the most important thing to remember is that in some cases, it's not that the engineering team is unwilling to take on the bug or whatever gets filed, the issue that gets filed. Sometimes there is just an unseen iceberg of work that is happening just outside of the community's eyeballs. And so sometimes, while we do a good deal of scheduling in the public, that you might see a thing that happens in a, where you're like, oh, crumbs, my thing went away. Oh, James, thank you for that blocked eval reference. You are the best. But I encourage people that if that should happen, please rally your upvotes again, because, that will help keep it on the radar. We do these are great moments to sort of surface a thing. Don't hesitate to kindly go to a forum. Discuss is a great place to sort of talk about things. And, if you have a SAD that, you might be able to sort of encourage people to say, hey, I've got this issue, and I really, it would be great if more folks were upvoting it, because, it's super hard to me it's causing me pain, and it's probably going to cause you pain because I know that you are a powerful user of the product. You like to get into all the corners, and that we also appreciate that too.
I think that's really what it comes down to. We take your feedback and we do something with it. It's not always visible, but it is definitely read and acted upon. Apologies for that. And as Amir pointed out, don't be afraid to ping us what the status of a bug is. We are usually around on the forums on discuss.hashicorp.com. There's edit this page links on a lot of our tutorials, on documentation. It will show up in a way that the team can see it. And then, OJ, thank you for all these amazing questions today.
Very exciting. So I do know that while we do not have it's not a direct integration with Loki, there is an example, and I'm digging through my mental Rolodex of weird example jobs. The Autoscaler Learn Guide, if my little memory serves, has an example job, and the example job for the Autoscaler has a Loki setup in it so that you can see the points where the Autoscaler scales. So that Loki job is watching the Autoscaler jobs logs. So it would be a fun one to look at if you wanted to see how an integration with workload, not so much Nomad, but you could actually mount in your logs if you wanted to a Loki instance internally. Or you can also off-box, if you're just talking about, I want to watch my client logs generally, you would use any of your standard client log exporters to go wherever you might like them to go, because we just write to typical log paths. So, we write out to standard out, basically. So it's not, so wherever you plumb standard out for your Nomad service for logging is where it will end up.
Beautiful. And Luis actually suggested a really good tutorial here, the test drive the Nomad autoscaler with Vagrant tutorial. So you can set everything up easily and locally. And we'll get a link for that in the show notes, but also in the chat, so we can highlight it for you. And there we go. By the magic of the internet, you should now be able to see that link.
Yes.
And this is a good tutorial path. It talks about a couple of the features that features and concepts actually that you'll need to understand. So it's not just Nomad specific. You'll become a better operations engineer by following the whole tutorial. I'm a huge fan of this one actually.
It's really very I enjoy it just because it really does sort of get you a chance to play. It's like, oh, this is Nomad and an APM and the load balancer, and how are my load balancer policies interfacing with my APM. And this is one of my Charlie soapboxy moments. Anybody who does a real Nomad deployment, please have a metrics layout. Please collect your metrics in a metric system that is not deployed in Nomad, because monitoring the thing while it's running inside of the thing you're monitoring never works out like you'd hope. Okay, Kerim, thank you for the full screener there.
A soapbox moment deserves a proper stage.
I needed some dimmed lighting and like a little vignette around me, sort of a more shooting star.
We'll work on that for the future, but I think the call out here is very important. Don't have the watchers be the one that are being watched by the watchers. It's not going to work out the way you think it will. And even if you think, hey, my application is really small, I don't need to monitor it right now, build up historical data. There's plenty of solutions that you can use down the road. Storage is cheap, right? Storage is cheap right now. Storage will be cheap down the road, because if you get to a scale where storage is no longer cheap, then your scale will allow you to make storage cheap. Again, it's a conundrum, but it does work out. So get that historical data, because down the road, you'll be able to determine how your system behaves, what the health is. Is your system sputtering at certain hours of the day, and is that related to something? You'll be able to detect the outliers with tooling or without, because you have that historical data. And with that, let's grab another community question. You can definitely ask specific questions, and in this case, will there be Nomad template change semantics for rolling update behaviors?
That is an excellent question. I know that is an issue that people are watching. We are paying attention to that one. I'm sort of watching my side chats here. I'm like, come on, folks. But yeah, this is the thing we are aware of, just because once you get that system job out there, the weird jitter semantic that, and for template updates, I know that it doesn't handle all the use cases well. Let's put it that way. Try and get out of that as gracefully as I can.
I think, as somebody with operational experience, I still am looking for that one system that handles every use case I throw at it perfectly. This is not to shill for Nomad. It's just the inherent imperfection of technology. Bit rot occurs. Your code that worked today will not work tomorrow for no apparent reason. No, updating Python to 3x is not the reason for that. And that pull request you push through, even though the checks didn't check out, is also not the reason stuff is breaking. So all we can do is optimize our systems as well as possible, and log it, and log it. So that's actually a good question, though. It's not really a question, but what debugging techniques would you two advise people who use Nomad?
Oh, golly. Yeah, there's an aggressive amount of logging, and getting logs where you can visualize them is important. Honestly, practice your debugging before you need it. Write bad stuff and see what bad looks like. Because while we can catch something, errors can manifest in several different parts of how the job gets sent out. Some things we can catch at parse. Some things we can catch when it hits the client. Some things we can only catch when we really try and start the job. And so there are multiple failure states even along the pipeline, because it's quite complex. So, play around with what happens if I write an invalid job? What happens if I write a job that is valid, but, flaky? What happens if I write a bad template? All of these sorts of pieces because as platform operators, in many cases, when you're really thinking about that, I'm debugging Nomad. You're the platform owner, so your users, your end users, are going to provide weird stuff, and they're probably not going to read the docs great, even though you've told them 100 times. But they're going to be like stuff, and you're that job's going to run. And you're going to be like, oh gosh, and they're going to be like, my thing doesn't work, and that's that moment where you're like, you have to sort of outdumb your users. Yeah. And I like to call it, creative chaos. I sometimes will just creatively imagine ways that I think I might be able to break a thing. And for people who've known me long enough, they've seen my example jobs repo, and it is full of all sorts of things that are just awful. And because I could use those as, time bombs, or, so that I could test behaviors that I needed to really understand well. And I wanted to be able to see what the logging looked like.
I think that is a hard one to build onto, but I do love the idea of practice debugging before you need it. It's no different than test your disaster recovery plan before you need it. when it's 3 a.m. and you're wondering if that PDF was actually recently updated or not, that's too late. You need to have that down. Even if everything is codified, there's still going to be some magical parts that have to be tried and tested. Maybe there's a ceremony involved. Maybe there's something else that you need to do at a different level just because of your application landscape. Train for these things before you need them. And I think that example repo, we should get a link of that up because
Not yet.
yes, because there's definitely some good stuff in there. It's nice to understand how your system is operating, you know, when the engine of the instance is purring as it should, and, you know, when it isn't.
Yeah. I mean, and the other thing is it's amazing that some things will really work in spite of being goofy. You know, where you'll have the failing instance that just, it recovers itself because Nomad sees it's gone and it's like, oh, I should put that back. So, you know, sometimes, you know, it can help you too much. And so really having your eye on it and making intentional failures to handle those places where in a normal case, it would recover and just make that invisible to you.
Reliability is never an accident. It is the byproduct of consistent behavior and proper engineering techniques. And preparing, always preparing.
I like OG's question. Excited about this one. Yes.
Let's head on over to this one.
So yes, current swarm clusters of satellites in AWS regions. So in Nomad, the idea here would be a multi-region cluster. And yes, you can federate across multiple regions. You can look at them. And, you know, to Nomitch's point here, more exciting stuff coming very, very soon. I also like that Shantanu's point about sometimes things just have to line up. Stand on your head, point a direction, and hope the thing is good and magic.
Yeah, and otherwise, just lint your code before you commit it. And then for our final question for today, how about a second?
Quick question.
Oh, quick question. There we go. Thank you.
QQ.
About system jobs and rolling updates. Yeah. What was the second question that we missed here? I'm not seeing it, but I think, first of all, thank you to our audience for all these beautiful questions. I love the interactivity here. I was told that Wednesday was going to be a quiet day. It was not. Thank you for proving everyone wrong. Anthony, kick butt demo at the beginning. Beautiful that it worked out, and
yeah,
not just that.
Happy that it did.
It looked great, and it provided a lot of inspiration. I love that we have a Learn tutorial for that as well. Charlie, as always, the quick start is beautiful. I'm excited for the changes that are coming. And to your audience, please check out Nomad Pack, check out the Learn Guide, give us feedback on these things so we can make them better for the next iteration. And I think we'll see all of you for the Nomad 1.3 office hours, where we're going to talk about some cool new features.
Oh, yeah.
And with that, have a great rest of your Wednesday. Or if you're watching this in the future, whatever day it is.
Could also be Wednesday.